Slide 1. Welcome to Networking and Health Information Exchange Enterprise Architecture Models. This component, Networking and Health Information Exchange, is an in-depth analysis of data mobility, including the hardware infrastructure, wires, wireless, and devices supporting them, the ISO stack, standards, Internet protocols, federations and grids, the NHIN, and other nationwide approaches. Slide 2. The objectives for this unit, Enterprise Architecture Models, are to explain regional healthcare networks, policy and implementation strategies, explain the concept of a nationwide healthcare information network, explain the significance of service-oriented architecture in networking and health information exchange networks, explain the value of an enterprise architecture in networking and health information exchange networks, and describe key elements of various service-oriented architecture platforms and infrastructure options. Slide 3. Who needs interoperability? Two or more groups interested in collaborating and sharing healthcare, life sciences data, information using computer systems, and electronic interchange. There can be no assumptions. The system can be of any scale, nations, enterprises, or individuals. No assumption of what is being exchanged, how it is exchanged, or why. Slide 4. Service-Oriented Architecture, or SOA, is an automation of common services shared across a community. In this case, we are focused on common services shared in the healthcare community. It ensures functional consistency across applications. It minimizes duplication across applications and is reusable. Service modules are created that can be used by anyone. Messages can be either payloads in or infrastructure beneath, services that provide the interface and communication with modules. SOA is an accepted industry best practice and has been required by the Office of the National Coordinator, or ONC, for recent grants. Many key products use SOA but do not expose interfaces. Users just have to understand the data format. Slide 5. SOA is a flexible set of design principles used during the phases of system development and integration. SOA-based architecture provides a loosely integrated suite of services that are reusable. These services function similarly to subroutines in computer programs. SOA becomes more important with the availability of web services. This means that you are able to put service modules anywhere and build them into systems. Slide 6. SOA interface is defined in terms of protocols and functionality. SOA separates functions into distinct services using HL7 and EHR models to identify the services. They are accessible over a network in order to permit users to combine and reuse them in different applications. Data is passed in a well-defined format. SOA service is self-contained and makes no calls out of its service package to anything else. If changes occur outside a service, then there is no impact on the service itself.
Services perform specific tasks, have a well-defined interface, and may use different implementation languages. Extensible Markup Language, XML, is commonly used for interfacing with SOA services. The data input stream is defined by XML format tags that identify characteristics of data. SOA contrasts with the EHR software that is produced by an Application Programming Interface (API) approach. SOA provides flexibility, and modules can be updated or even exchanged simply. API doesn't have flexibility or independence. In API, if you change something, it impacts the rest of the API system. When you change something in SOA, functionality is preserved.
Slide 8. SOA supports integration of diverse classes of information and distribution across a distributed heterogeneous research and care community. Clinical trials can easily be done in SOA systems by creating a module to pull data out of an EHR system. SOA enables coordination of functionality between inter-enterprise information systems and collaborative data processing and workflow execution. SOA's services can be implemented in a standalone fashion. It also allows for the rapid creation of composite applications. Slide 9. XML is typically used to structure data that is wrapped in a nearly exhaustive description container. You can include as much data as you want. You are not restricted to a certain number of data elements. Web Services Description Language, or WSDL, describes the services. Simple Object Application Protocol, or SOAP, describes the communication protocols. Slide 10. SOA permits developers to string together large chunks of functionality to build applications. Ideally, applications will be built almost entirely from existing software services. Building an application is like taking a set of blocks, each representing a service, and stringing them together to create the application. Slide 11. SOA relies on service orientation as its fundamental design principle. Its simple interface can abstract away the underlying complexity. Users can access independent services without knowledge of the service's platform implementation. The complexity is hidden from the user. They just have to understand the data that is required for the package. They don't have to worry about what happens inside the black box. Slide 12. You can use any Master Patient Index, or MPI, without reintegrating. The data are independent. MPI is a database that maintains a unique index or identifier for every patient registered at a healthcare organization. You just link modules together. You can painlessly integrate data from new clinical systems into a patient's health summary by having a module that pulls data from all sources to create the summary. Heterogeneous systems can be accessed consistently from your installed application base by simply meeting the requirements of the service functions. SOA standards support the ability to redeploy or distribute hardware and software without breaking things. In the old days, if we switched the hardware or software, it affected the application, but an SOA application is not affected by changes. Slide 13. In order to use SOA, we must have interoperability between different systems as the basis for integration between applications on different platforms through a communication protocol like Transmission Control Protocol, Internet Protocol, or TCP/IP. Messages are used across channels for communication and transfer of data. If we are going beyond a single organization, for example, a regional health information system, then we can set up a common business format for each data element to orchestrate a system that will allow us to bring data together. If a hospital or clinic changes from application vendor A to application vendor B, and if vendor B is able to interface with the SOA, then we are able to make changes without affecting the entire system. SOA lets us create a federation of resources. Data flow is established and maintained in a federated database, allowing new functionality developed to reference a common business format for each data element. Slide 14. The guiding principles of an SOA are service encapsulation, service loose coupling, service contract, service abstraction, service usability, service composability, service autonomy, service optimization, service discoverability, and service relevance. Slide 15. The service contract includes the name of service, version, owner, responsibility assignment, and type. That is, presentation, process, business, data, integration. It defines the product you are building. Slide 16. It includes what the service accomplishes, service operations, and how to invoke the service, that is, SOAP, event triggers. An example of an event trigger would be if you give the system a patient's weight and height. The system would give you the Body Mass Index, or BMI. Slide 17. The service contract also includes non-functional information like security constraints, quality of service. For instance, is service guaranteed 24/7? Is it up 99.999% of the time? Translational considerations, including translation between different kinds of data and coding systems, service level agreement, semantics, and process. Slide 18. The intersection of HL7, MDA, Distributed Systems Architecture, SOA, and CSI provide a goal, the artifacts, portions of a methodology, and the framework for defining robust, durable, business-oriented constructs that provide extensibility, reuse, and governance. It uses a reference model for open distributed processing that defines communication protocol use. It also has a model-driven architecture that defines data elements and characteristics. Slide 19. In an EA, how do all the pieces fit together? There are 5 viewpoints to look at an EA. The enterprise view is the why. It involves the purpose, scope, and policies of the specified system. Why should we connect 16 hospitals and 5 clinics to each other? We want a flow of data and work. The information view is the what. What type of information needs to flow between the different entities? How is covered in the computational view. How do we share information? Do we share just part of the record or the entire record? The engineering view covers the where. Where is the physical information structure? This is where we look at scalability and sustainability. Lastly, the technology view covers what is required to support the system. A new approach in the engineering and technology views is cloud computing. Cloud computing has a positive impact on SOA and EA because we don't have to worry about where service modules are. They can be replicated, and there are mechanisms in cloud computing that will allow the user to access the most efficient module at any given time. Slide 20. SOAs appear in the design of loosely connected inter-organization health information technology, or HIT networks, as the desired way to interconnect widely distributed systems. SOA is particularly attractive when no one organization owns or controls all of the applications and platforms. With cloud computing, Health Information Exchange, or HIE, and Nationwide Health Information Network, or NHIN SOAs, are attractive because we can use a service that is provided by a service provider to build our applications. There is interoperability between the different systems. Sometimes people mix up SOA and web services. Web services are an enabler for SOA. SOA is not a technology or transport platform or an industry standard. Web services are. SOAs are primarily business-owned and affect workflow and business processes. This is not true with web services. Both SOA and web services enable business and IT transformation. SOA is moving toward standardization. Slide 21. How is SOA different from messaging? It is a common practice in healthcare, just not yet in healthcare IT. Many key products use them but do not expose interfaces. It ensures functional consistency across applications. It is an accepted industry best practice. It furthers authoritative sources of data. It minimizes duplication across applications, provides reuse. Messages can be either payloads in or infrastructure beneath services, and its service-oriented architecture provides the framework for automation of common services. Still, SOA has to be done well. It is cheaper and easier than ever to create badly designed applications and spaghetti integration. It fits well with open source.
HL7 created a framework for interoperability for EA called HL7 Services Aware Interoperability Framework, or SAIF. It uses version 3 RIM artifacts and expertise, supports measurable, testable conformance and compliance, and provides directly implementable solutions. SAIF has 4 defined areas: Services, Awareness, EA, and Framework. 1. Services. This is about services enabling HL7 standards. 2. Awareness. This is about making our standards aware of both services and an enterprise architecture. 3. Enterprise architecture. When adopted and embedded in our development methodologies, SAIF becomes our enterprise architecture. 4. Framework. This is a framework in which we will place our standards so that we can see how they relate to each other and they relate to other standards and becomes part of our users' integration architectures.
Slide 24. The core components are Information Framework, Behavioral Framework, Enterprise Conformance and Compliance Framework, Governance Framework, and an Implementation Guide. The guide provides examples of how you put things together. Slide 25. HL7 standards are being developed for entity identification, records location and retrieval, decision support services, and terminology service. Entity identification is used to manage and maintain identities within and across domains, localities, or products. Record location and retrieval is used to discover, retrieve, and update records in distributed environments. Decision Support Services supports evaluation processes such as clinical decision support. Terminology services are used to retrieve, maintain, and navigate clinical terminologies and ontologies. Slide 26. These specifications would be used in inter-enterprises like National Health Information Network and Regional Health Information Organizations to functionally specify behavior, to clarify roles between applications and products, and to profile and sharpen the technologies supporting them. In intra-enterprise, the standardization would allow better integration of off-the-shelf and custom development environments, and promotes more of a plug-and-play environment. With intra-product relationships, the specification would facilitate a vendor's ability to integrate third-party value-add components and speed design phase with higher confidence. Lastly, within custom implementations, it would provide the opportunity to later integrate off-the-shelf products with custom products. Slide 27. Services, in particular, are more coarsely granulated than messages and are more readily traceable to business, clinical capabilities, and requirements. They are specifications for a service that are of the following form: functional profile, collection of operations offered by a service, and semantic profile, static semantics utilized by operations in FP, and conformance profile, testable, automated, or human conformance standards against which an implementation may make pairwise conformance assertions. The combination of the 2 points above provides a foundation for both intra- and inter-enterprise durable services interfaces. Slide 28. Healthcare Service Specification Project, or HSSP, is an effort between HL7 and Object Management Group, or OMG, to create common service interface specifications. The objectives of the project are to create useful, usable healthcare standards that address functions, semantics, and technologies, to complement existing work and leverage existing standards, to focus on practical needs and not perfection, and to capitalize on industry talent through community participation. Slide 29. The U.S. government has become involved in the development of standards for data exchange, so SAEAF has had a name change. The new name is SAIF, which stands for Services Aware Interoperability Framework. This new name brings emphasis to the word interoperability. Interoperability is the key word as we look at the development of new SOA and EA systems to share health information data. Slide 30. This concludes enterprise architecture models. In this unit, we have discussed regional and national healthcare networks, SOA and EA.